Hello everybody. In this video we'll be talking about stress and strain. So to get started, let's say we have a beam with an axial load. So an axial load is presented over here, so the forces are in the same direction as the part. So let's call the force P. So to get the stress, which if we want to represent it graphically, it would be this. So on every unit area, this was stress. So to get stress, we just divide the force P by the cross-sectional area, and the unit of stress is force per meter squared, or which newtons per meter squared if we're using SI units, or pound per foot squared if we're using the English system. Now let's talk about shear. Let's say we have the force F perpendicular to the direction, so it's opposite as of the axial load. Now we have here V, which is going to be equal to F. So to get the shear, it's going to be the force over the cross-sectional area. Or we can, the more usual representation is V over A, which in this case V equals to F. Now moving on to strain. Strain is just simply one small equation, so strain average is the change in length, which is represented here, over the original length. So let's say we have a beam, this is for axial by the way. Let's say we have a beam, force P. As such, let's say the original length was 5 meters. Afterwards, it was 6 meters. So the strain would be 6 minus 5 over 5 equals 1 over 5. And it's unitless, since this is going to be in meters, and this is meters as well. So it cancels out. Now this is just to get it's kind of an introduction. Those will be used in later chapters. Thank you everyone for listening.